Hello and welcome back to Higher Maths, Polynomials and Quadratics Synthetic Division. So we're going to look at the factor theorem and remainder theorem now. So we've actually been using this for the last few videos. I'm just going to formalize what we've looked at. So for a polynomial f of x, so that's just any polynomial we've been looking at. So here's an example of one down here. If f of x is divided by x minus h, then the remainder is f of h. So that is essentially what we're doing when we're doing the process of synthetic division. Okay, we're dividing f of x by x minus h. So here we are dividing by x plus 1. So remember, if x plus 1 is a factor, then x equals -1 will be a root. We need to use -1 at the front. And if f of h equals 0, that means x minus h is a factor of f of x. Okay, so we've seen that in this example. Again, we are just formalizing what we've been doing. We're not looking at anything new just now, but we are going to talk about the remainder theorem as well. So as we saw, synthetic division helps us to write f of x in the form x minus h, so the factor multiplied by q of x. Q of x is the quotient, which is given by these values down here, and f of h is the remainder. So find the quotient and remainder when f of x is divided by x plus 1. So we have x plus 1 there, so we need to solve that equal to 0 to get the value of x that we're going to substitute in. So it's going to be -1 that we substitute in. Repeat the process of synthetic division. That gives us a remainder of -3. So f of x, 4x cubed plus x squared minus x minus 1, is equivalent to x plus 1, which is what we're dividing by, multiplied by the quotient, which is these three numbers down here, 4x squared minus 3x plus 2, and then plus the remainder, which in this case is going to give us -3. So f of x equals x plus 1 bracket 4x squared minus 3x plus 2 minus 3.